In this video, I'll be solving the 15th question of JEE Advanced 2025 paper 1. So we were given 4 different questions in this matrix matching. So the first question is f of x is box of 10x cube minus 45x square plus 60x plus 35 by n. And we're asked to find the minimum value of n for which this particular function, the box function, is continuous. Now, like a box function is continuous, a function involving a greatest integer function will be continuous only if it is the same integer throughout that interval from 1 to 2. So now, like if we consider f of x as, or like if I just consider like some h of x as this function, or like there is another h of x, let me just take it as some function, some p of x, the polynomial, as 10x cube minus 45x square plus 60x plus 35. So now p dash of x will just be 30x square minus 90x plus 60. So that means like it is nothing but 30 times x square minus 3x plus 2. So that means it is 30 times x minus 1 into x minus 2. So that means like if we see the differentiation of this p of x, we're having it something like this, like at 1 and 2 it is getting 0. So that means like this p dash of x is less than 0 if x belongs to 1 to 2, and this p of x is decreasing. So that means like we can say it is decreasing in 1 to 2. Now like if we try to see the function, so if we try to plot the function, so the function will be something like this. So like until 1 like it is positive, so that means it is increasing till 1. So let's say it is something like this. At 1, like if we find the value 10 minus 45 plus 60 plus 35, which is 105 minus 45, which is 60. So let's say at 1 it is 60, and at 2, so at 2 it will be 80 minus 180 plus 120 plus 35. So that is like 115 plus 120. So 115 plus 120 is like 235 minus 180. So that means it is 55. So at 2 it is 55. So that means it is something like this. Right. So that's the graph of this p of x. At like in between 1 and 2 it is like decreasing, like in between 60 and 55. So now, so that means like in between the 60 and 50, like it should have the same integral value, otherwise it will be discontinuous. So essentially our solution will become 60 by, like box of 60 by n is box of 55 by n. So we can check for like each option, because it's not, I mean that's like we can't solve this box function thing, because it's the denominator, like we're having n in the denominator. So now let's start with the minimum value. Let's start with 5. So if we start with 5, like this is 12 and this is 11, so that is not continuous. And if you take 6, so this is 10 and this is 9, so that's not a possibility. Now if we take 8, so 8 7s 56 and 8 6 48, so that is not. And if we take 9, so 60 by 9 is 6, and 55 by 9 is also 6. So basically the least, the minimum value of n that makes this thing as this function f of x continuous is n is equals to 9. So that's the minimum value, because out of the given options we have checked 5, that's not possible, 6 it's not possible, 8 it's not possible, so 9 is the possible thing. So yeah, so the answer will be 9 for the first one, because the function inside the step function or inside the greatest integer function must be of same integer. Like it should not, because our box function is not continuous at integers. So we should have like the same integer like throughout this 60 to 55. It should not change our integer when we divide by n. So that's the reason why our minimum value of n should be, the value of n that satisfies this equation is 9. Now if we take the second question, the minimum value of n for which g of x is an increasing function. So if we take like g of x, so g of x is 2n square minus 13n minus 15 into x cube plus 3x. So g dash of x, the differentiation will just be 2n square minus 13n minus 15 into 3x square plus 3. So now like for this to be increasing, this 2n square minus 13n minus 15 must be greater than 0, because the second term 3x square plus 3 is anyways like greater than 0. So now this means like 2n square minus 15n plus 2n minus 15 is greater than 0. That means n times 2n minus 15 plus 1 times 2n minus 15 is greater than 0. So n plus 1 into 2n minus 15 is greater than 0. So that means like either n is less than minus 1 or n is greater than 15 by 2. So the minimum value of n that satisfies, that is greater than 15 by 2 is 8. So basically for this it will be 8 and for this it will be 9. And if we see the third question, so in the third question, like the smallest, we need to find the smallest natural number n for which for smallest natural number n which is greater than 5, such that x is equals to 3 is point of local minima of h of x, which is x square minus 9 whole to the power of n into x square plus 2x plus 3. So h dash of x will be n into x square minus 9 whole to the power n minus 1 into 2x into x square plus 2x plus 3 plus x square minus 9 whole to the power of n into 3x plus 2. 2x plus 2. So that is equals to n into 2x into x square plus 2x plus 3 plus x square minus 9 into 2x plus 2 into x square minus 9 whole to the power n minus 1. So that means this is equal to 2n into x square plus 2x x cube plus 2x square plus 3x plus 2x cube plus 2x square minus 18x minus 18 into x square minus 9 whole to the power n minus 1. Now for a particular point of local minima, so that means like our h dash of x should go from positive to negative, right? Like so it should be like negative to positive. So like if h dash of x is less than 0, that means like function will be decreasing. Now h dash of x is greater than 0, that means it is increasing. So at this point, like just before this point, our h of x should be decreasing, and just after that point our h of x should be increasing. So if we try to see like this quantity is like positive at x is equals to 3. Now this quantity is 0 at x is equals to 3, and this is also 0 at x is equals to 3. Now so at just less than 3, this entire thing is positive and this thing will be negative, right? So just less than 3 it should be negative, and like just greater than 3, so this should be negative, because like if this is positive, because like this is always positive, this entire thing is always positive. So at just x less than 3, just before 3, our h of x should be decreasing. So in order to have a local minima, or just before this x is equals to 3, the h of x must be decreasing. Now in order for that to be decreasing, so that means like this should be negative. Now when will this be negative? So this will be negative, so n minus 1 is negative. So just less than 3, in the left neighborhood of 3. So x square minus 9 whole to the power n minus 1 is negative. So that means n minus 1 is odd. That means n is even. Now in the question they have specially given smallest natural number greater than 5, and we also need an even number. So that means n minimum is 6 in this case. So here it will be 6. Now if we take the last part, like we need to find the number of x naught belongs to R such that L of x, which is summation k is equals to 0 to 4 sine of mod x minus k plus cos of mod x minus k plus 2 is not differentiable at x is x naught. So we are having L of x. So if we consider L of x, so that is equals to summation k is equals to 0 to 4 sine of mod x minus k plus cos of mod x minus k plus half. So this thing, like at x belongs to R. So we need to find number of x naught such that this L of x is not differentiable at x naught. So basically we need to find points of non-differentiability of this thing. So first, if we consider the graph of sine of x minus k, so sine x minus k, so the graph will be something like this, like at k it will be 0, and from k to k plus pi it will be like this, and k to k minus pi it will be like this, and it will have a period of period of 2 pi. So now like sine mod of x minus k, so here like sine x minus k will be something like this. Now sine mod of x minus k will be something like this at k. So basically it will have reflection with respect to y-axis. So whatever the values that we are having on the left hand side of, not y-axis, like, but at x is equals to k. So the graph will be something like this. So that means at this point at x is equals to k, we are having point of non-differentiability. So basically this will be k, this is k plus pi, this is k plus 2 pi, k plus 3 pi, this is k minus pi, k minus 2 pi, k minus 3 pi. So basically sine of mod x minus k will have point of non-differentiability at x is equals to k. Now in the similar way, like if we can plot the graph of cos of x minus k. So cos of x minus k at k, it will be 1. So let's say this is at k. So this will be 1. And so this is at k plus pi by 2, k plus 3 pi by 2, k plus 5 pi by 2. In the same way here k minus pi by 2, k minus 3 pi by 2, k minus 5 pi by 2. So if we see the graph of cos mod x minus k, it will be the same because the reflection with respect to x, x is equals to k, will just be the same. Like though we are doing like mod for x, so the reflection with respect to this x is equals to k will be the same. So because already like we are having it reflecting with respect to this line x is equals to k. So that means like cos of mod x minus k is differentiable everywhere. Differentiable everywhere in x belongs to R. So that means like, so we are having sine mod x minus k. So if we see our function L of x, so that is summation k is equals to 0 to 4 sine mod x minus k plus cos mod x minus k plus half. So we don't have to worry about cos, but like sine, like it's not differentiable at x is equals to k. So here we are having 5 different values of k. So points of non-differentiability, so number of points of non-differentiability will be 5, and they will be 0, 1, 2, 3, 4. So they will be the points of non-differentiability. So if we see this one, this will be 5. So the correct option for this question will be option B. So that's it for this video. We'll meet in the next